Dear students, as you all know that in our previous videos, we discussed 40 questions of CET 2020 physics paper. For those videos, you can click on the links given in the description. In this video, let me continue my discussion with the 41st question. Okay, let's get started. Let's have a look on the 41st question. Two poles are separated by a distance of 3.14 meter. The resolving power of human eye is 1 minute of an arc. The maximum distance from which you can identify the two poles distinctly, that is separately, is. So here are the two poles which are separated by a distance of how much? That is 3.14 meter. And we need to find out maximum distance. Let me consider this is the maximum distance from which you can identify these two poles separately. And the theta is very, very small here. That theta is the resolving power of the human eye, that is equals to 1 minute, and this should be expressed in radian because it is 1 minute of an arc. So 1 minute can be written as 1 by 60 degree, and this can be written as 1 by 60 times pi by 180. This gives us the theta in radian, that is pi divided by 60 is 18 into 6. So pi divided by 10,800 radian. This is the theta. As theta is very, very small, we can consider sin theta is equal to the tan theta, and that is equals to L divided by D. So here is the distance. This distance is D. So therefore we can consider L divided by D. Now, as the theta is very, very small, sin theta equals to tan theta, and whenever we are considering the theta is very, very small, at that time sin theta becomes theta and tan theta becomes theta also. So therefore we can write L divided by D equals to theta. Now actually what we want D, that is the distance from which you can identify the two poles separately, that is L divided by theta. On substituting, that is 3.14 divided by theta is pi divided by 10,800. Pi and 3.14 to get cancelled, we'll get 10,800 meter. So this is nothing but D equals to 10.8 kilometer. So option A is the right option. Okay, so moving to the next question. In Young's double slit experiment, the distance between the slits and the screen, that is D, 1.2 meter, and the distance between the two slits, that is small d, is 2.4 millimeter. If a thin transparent mica sheet of thickness 1 micrometer, that is thickness 1 micrometer, and refractive index, that is mu equals to 1.5, is introduced between one of the interfering beams, the shift in the position of the central bright fringe. So whenever we place any transparent material in the path of one of the interfering fringe, at that time there will be shift in the position of the central bright fringe. So whenever there is no transparent material in the path of the interfering beams, at that time we will get the bright fringe at the central bright fringe we will get. So whenever we place any transparent material in between one of the interfering beam, at that time there will be shift in the position of the central fringe. So this is what we call shift in the position of the central fringe. So this shift is given by the expression, that is d divided by d of mu minus 1 into t. Here the distance between the slits and the screen is d, and the distance between the two slits equals to d. Now the shift in the position of the central bright fringe is given by d divided by d of mu minus 1 into t. That is, as we know that d equals to capital D is 1.2 meter divided by small d 2.4 millimeter, that is 10 to the power of minus 3 into mu, that is refractive index we have, that is 1.5 minus 1, and thickness equals to 10 to the power of minus 6. As you know that 1 by 1.2 divided by 2.4 is 1 by 2, 10 to the power of minus 3. Here 10 to the power of minus 6 we have, so it will become 10 to the power of minus 6. So 1.5 minus 1 is 0.5 into 10 to the power of minus 3. Here 0.5 divided by 2 is nothing but 1 by 4 into 10 to the power of minus 3. So 1 by 4 is 0.25, 10 to the power of minus 3 millimeter. So therefore option D is the right one. Okay, moving to the next problem. The de Broglie wavelength associated with the electron of hydrogen atom in this ground state is, as we know that in the ground state the energy of the electron, that is kinetic energy of the electron, is equals to 13.6 electron volt. This kinetic energy can be written as electron times the potential, that is equals to 13.6 electron volt. So therefore E and E get cancelled, we get P equals to 13.6 volt. As we know that the de Broglie wavelength is given by the expression, that is 12.27 divided by root V angstrom. And here we have V, so on substituting the value, that is 12.27 divided by root 13.6. So we know that root 13.6 is equals to 3.68 on approximately 3.68. So on simplifying this 12.27 divided by 3.68, we will get 3.33 angstrom. That is option B is the right option. Okay, moving to the next question, that is, the following graph represents the variation of photocurrent with anode potential for a metal surface. Here I1, I2 and I3 represents intensities, and gamma 1, gamma 2, gamma 3 represents frequencies for curves 1, 2 and 3 respectively. Then by analyzing this graph, we can understand that the photocurrent is different for first and second curve. If the photocurrent is different, then intensity of incident radiation will be different, because the photocurrent is directly proportional to the intensity of incident radiation. For that reason, I1 is not equals to I2, as the photocurrent is not same, and I2 is equals to I3, because for curve 2 and 3 the photocurrent remains same, so therefore intensities for second and third will be remain same. Next, coming to the frequencies, as we know that the stopping potential depends on the frequency of incident radiation. Here the stopping potential for the first and second curve is same, so therefore the frequency of the first and second curve will be same, that is frequency of the first equals to frequency of the second, whereas the frequency of the third curve is more, because its stopping potential is more, so therefore it will be having more frequency, that is third curve. So here we can observe that the gamma 1 equals to gamma 2 and I1 is not equals to I2 and I2 equals to I3. So in the given options we can observe that gamma 1 equals to gamma 2 is in option A and I1 is not equals to I2. Yes, option A is the right option for this question, and remaining option we won't see. So I1 is equals to I2, so therefore this is not correct answer. So option A would be the right one. So moving to the next question, that is, the period of revolution of an electron revolving in nth orbit of hydrogen atom is proportional to, here the period of revolution they are asking. So as we know that T equals to the distance divided by velocity. For one revolution of an electron, we can consider this is 2 pi r divided by velocity. As we know that the radius of an electron, that is radius of an electron, is directly proportional to the n square, and then velocity of the electron in the nth orbit is inversely proportional to the n. So therefore we can write here T, see here 2 pi is constant, so therefore T is directly proportional to r divided by v. Here we can write now, in place of r I could write n square divided by, in place of v I will write 1 by n. So therefore the T is directly proportional to n cube. So option C is the right one. So moving to the next question, that is angular momentum of an electron in the hydrogen atom is 3h by 2 pi, where h is the Planck constant. The kinetic energy of the electron is, as we know that the angular momentum, that is mvr, is equals to nh divided by 2 pi. This is from Bohr's postulate. We can write angular momentum is equals to integral multiple of h by 2 pi. So clearly we can see that on comparing these two, we can get n equals to 3 here, because here 3h divided by 2 pi we have, then in place of n we have 3. As we know that the kinetic energy of the electron is equals to 13.6 electron volt divided by n square. So this is the expression for the kinetic energy of the electron in the nth Bohr orbit of hydrogen atom. Now 13.6 electron volt divided by n square, here 13.6 divided by n is 3, so n square equals to 9. So 13.6 divided by 9 electron, or 13.6 divided by 9 is nearly equals to 9 1 ja 9 1.451 electron volt. So here the option B is the right one. Okay, moving to the next question. A beam of fast moving alpha particles were directed towards a thin film of gold. The parts A, B and C of the transmitted and reflected beams corresponding to the incident parts A, B and C of the beam are shown in the adjoining diagram. The number of alpha particles in. So from the observations of Rutherford's alpha scattering experiment, we have seen that most of the alpha particles move in a straight line through the gold file. Most of the alpha particles move in a straight line through the gold file. Here the straight line, here A dash representing the straight line. So therefore the A dash having more number of alpha particles, that is most of the alpha particles is present in A dash. So therefore A dash will be having maximum number of alpha particles. And one more observation we have, which says that about 1 in 8,000 of incident alpha particles deflected by more than 90 degree. Here which one is deflected more than 90 degree? That is B dash. B dash is deflected by more than 90 degree. So therefore B dash will be having very less number of alpha particles, that is about 1 in 8,000. So therefore B dash having minimum number of alpha particles. So here we can see the options, that is A dash will be maximum, but here C dash is minimum. So here there are no such type of options, B dash is minimum. So therefore this question carries bonus mark. So actually option should be B dash, it should be B dash. A dash will be maximum and B dash should be minimum. Okay, so if it is B dash, then the option B would be the correct one. Okay, so moving to the next question, that is two protons are kept at a separation of 10 nanometer. Let Fn and Fe be the nuclear force and the electromagnetic force between them. As you know that nuclear forces are short range forces, that is the nuclear forces will come into play or they act when the separation between the two particles is less than or equals to 10 power minus 15 meter. But here the separation between the two protons is equals to 10 nanometer. This 10 nanometer is greater than 10 power minus 15, that is 10 to the power of minus 8 meter it will become, so which is greater than 10 power minus 15 meter. So the nuclear force is negligible in this case. Therefore electromagnetic force is very greater than nuclear force. So therefore option B is the right one. Moving to the next question, that is during a negative beta decay, an atomic electron is ejected, an electron which is already present in the nucleus is ejected, not possible. A neutron in the nucleus decays emitting an electron. Okay, a proton in the nucleus decays emitting an positrон, not electron. Okay, now Here during negative beta decay, as we know that inside the nucleus, electron is formed due to the conversion of neutron into proton, electron and antineutrino. So here the neutron in the nucleus decays emitting an electron. So therefore option C would be the right answer. The proton in the nucleus decays emitting an positron, not electron. So option C would be the correct answer. So moving to the next question, that is, a radioactive element has half-life of 15 years. Half-life of 15 years. What is the fraction that will decay in 30 years? As we know that the fraction of atoms left undecayed is given by the equation, that is fraction of atoms undecayed is equals to n by n naught equals to 1 by 2 power T divided by T of. Here we have, this is the fraction of atoms left undecayed, n divided by n naught equals to 1 by 2 power, here we have T equals to 30 years divided by T of is 15, so it will become 1 by 2, 30 divided by 15, that is 2, 1 by 2 power 1 by 4. So the fraction of atoms left undecayed is 1 by 4. Now the question is the fraction that will decay in 30 years. So therefore the fraction that will decayed is 1 minus n by n naught. This is the number of atoms left undecayed. So therefore 1 minus number of atoms left undecayed is equals to fraction of atoms that is going to decay. Okay, so therefore 1 minus n divided by n naught is 1 by 4. So therefore 1 minus 1 by 4 is 3 by 4. 3 by 4 is nothing but 0.75. So option C would be the right option for this question. Let's move to the next question. That is, a 220 volt AC supply is connected between A and B as shown in the figure. What will be the potential difference V across the capacitor? Here we have a diode and which is connected to the AC supply, input AC supply. See, during positive cycle of an AC, the diode is forward biased and it conducts. Whereas during negative half cycle of an AC, the diode is reverse biased and it does not conduct. So therefore, the capacitor gets charged to its maximum potential only only during positive half cycle of an AC. So therefore, the potential difference across the capacitor is equals to the peak value of the voltage, peak value of the input AC supply or input voltage, that is equals to, we know that the peak value of the input AC supply is equal to root 2 times the RMS value of the input AC supply. So that is equals to, we have seen that the RMS value of input AC supply is 220 volt. So therefore, that is 220 root 2 volt. So the potential difference across the capacitor is 220 root 2 volt. So option D would be the right one. So moving to the next question, that is, in the following circuit, what are P and Q? In this circuit, we can see two NAND gates. So first let me draw the truth table for the NAND gate. That is, there are two inputs and outputs. Here the inputs are E, and let me consider two inputs, that is 0, 0, 0, 1, 1, 0, 1, 1. For this, the output of the NAND gate here 0. For 0, 0, will get output 1 for the NAND gate. If it is AND gate, then we could get 0 here, but it's a NAND gate, so we are getting 1. So 0, 1, 1, 1, 0, 1, 1, 1, 0 for the NAND gate. This is the truth table for the NAND gate. By this truth table, we can understand that a NAND gate gives an output. Look at that. A NAND gate gives an output 1. Output 1 if at least any one of the inputs is 0. In the diagram, here the input is 0 here. No matter whether it is 0 or 1, the output will become 1 only, because here you can see the truth table. If any one of the input is 0, then output will become 1. So therefore here one input is 0, then output Q equals to 1. If Q equals to 1, then the upper NAND gate, that is inputs of upper NAND gates, will become 1 and 1. For 1 and 1, the output of the NAND gate is 0. So therefore option B would be the right answer, that is P equals to 0 and Q equals to 1. Okay, moving to the next question, that is, a positive hole in a semiconductor is an antiparticle of an electron, a vacancy created when an electron leaves a covalent bond, absence of free electrons, an artificially created particle. We know that hole in a semiconductor is a vacancy which is created at the site of the covalent bond when an electron leaves the covalent bond. See, at the site of the covalent bond, hole will be created, that is vacancy will be created. So option here B would be the right answer. Vacancy created when an electron leaves a covalent bond. At the site of the covalent bond only, a vacancy will be created. That vacancy is called as hole in a semiconductor. Okay, so option B would be the right answer. Moving to the next question, that is, two long straight parallel wires are at a distance 2D apart. They carry steady equal currents flowing out of the plane of the paper. The variation of magnetic field B along the line x dash is given by. In the figure you have to see there are different types of graphs they have given, and then the equal currents are flowing out of the plane of the paper. So current is moving out of the plane of the paper. We know that the magnetic field due to the current carrying conductor, infinitely charged current carrying conductor, is B equals to mu naught I divided by 2 pi R. This is the formula for magnetic field due to the straight current carrying wire. That means the B is inversely proportional to R. For inverse functions or for inverse relationships, we will be having the graph like this. This is inverse relationship we are calling. The B magnetic field and the distance if I take, then the graph will be obtained like this. That is for positive. Suppose if it is negative direction, if the direction of the magnetic field is negative, then the graph will be like this. This is the graph. Keeping in the mind these two, let us analyze this problem. See, magnetic field is inversely proportional to the distance of point of concentration. So here the magnetic field is inversely proportional to the distance of point of concentration, but it is negative, but here positive. If it is positive, that means B is inversely proportional to R only, then we will get like this graph. If it is B is inversely proportional to the minus R, then we will get like this graph. Keeping in the mind this, let us analyze this one. Here there are two conductors which are carrying the current in the direction, so that the current is moving out of the plane of the paper. So these dots showing like this. Now we know that at this particular point, let me consider this is the first conductor and this one is second conductor. See, to the left side of the first conductor, there is a net magnetic field due to the first conductor as well as second conductor. Here is a net magnetic field. The direction of the net magnetic field here we can find out by using right hand thumb rule. So whenever we use the right hand thumb rule, the direction of the net magnetic field will be in the direction of minus j cap here at this point. So we will get minus j cap here. Okay. So if it is minus j cap, so if it is negative direction, what should be the graph? Graph will be here like this. This is the graph. Next, here you can see that at this particular to the right side of the second conductor, if I look, then the direction of the net magnetic field will be in the positive direction, that is positive j cap, by using right hand thumb rule. Here if you use right hand thumb rule, so that means in the right hand thumb rule, the thumb indicates the direction of the conductor, the direction of the current, and the curl fingers indicates the direction of the magnetic field. Here the curl fingers will be moving in the upward direction, so therefore I am taking positive j cap. If it is positive j cap, then what will be the graph? It is positive. I am taking B is positive, then we will get like this. Okay, na? Like this graph will get. By looking at these two only, we can decide the option here. Which option will be the correct answer? B would be the right answer. So let us analyze more this one. Here we have, let me consider the point is here, which is at a distance of x from the first conductor, and this distance will become 2d minus x from the second conductor. Now the net magnetic field at this particular point at P, let me consider at P due to these two conductors will be given by, that is B equals to, the magnetic field due to the first conductor is given by mu naught I divided by 2 pi, the distance of this point of consideration is x, and the direction of the magnetic field at this particular point, what will be the direction? The positive j cap, because you can see that here is the conductor at this particular point, this is negative, here negative j cap, and this side positive j cap here. So therefore we can write here j cap direction. Next here plus, due to the second conductor there is a magnetic field at the point P. At this particular point, what will be the direction of the magnetic field? Because of the second conductor, that is minus j cap here. Okay, at this particular point minus j cap, and then magnitude will be, that is mu naught I divided by 2 pi, the distance of this point from this second conductor is 2d minus x. Let me write 2d minus x, and direction is minus j cap. Now if I take mu naught I divided by 2 pi outside, mu naught I divided by 2 pi outside, then I'll get 1 divided by x, inside 1 divided by x, minus this negative I'll take inside, that is minus 1 divided by 2d minus x, and the direction is j cap. This is the direction, this is the magnetic field in between the two conductors. So now we can say that if x is equals to d, let me consider if x equals to d, what would happen? Let us see. If x is here, at the time what will happen for this equation? If I substitute the d in the place of x, I'll get I'll get the magnetic field equals to 0. You can see this one. By looking at this equation, you can understand that if x equals to d, then b would be equals to 0. That is exactly at this point. So the b is 0, will get magnetic field 0 exactly at the point. Because we know that the magnetic field due to the first conductor and the magnetic field due to the second conductor are equal in magnitude but opposite in direction. Plus j and minus j, they are equal in magnitude but opposite in direction at exactly in between the 2 points, in between the two conductors. So therefore magnetic field is 0 at this particular point. Suppose if x is less than, so let me consider x here, what it is, the x is less than d, then the magnetic field, the direction of the magnetic field is in the direction of, is, you can see that here, if you look at the diagram, if you look at the formula, if x is less than the d, if x is less than the d, then this value will become positive. So therefore we can take the direction of the magnetic field will be plus j cap. Plus j cap is nothing but, we'll get the graph like this here. So okay, this will become 0. Next, if suppose if x is greater than d, so that means x, if x comes here, then what will happen? If I consider this, if x is greater than d, at the time the b is in the negative j cap direction by using Fleming's, by using right hand thumb rule, okay, minus j cap. So therefore here we'll get graph like this. Okay, so this is 0. So now like this will get. So only one thing is, if b is inverse proportional r, at the time we'll get graph like this. So therefore exactly at the middle of these two conductors, the magnetic field is 0 because the direction of the magnetic field is just opposite to each other. The magnitudes are same but opposite, so therefore we'll get 0 here. So therefore by looking at this graph, we can mark the option now, which is that option B would be the right one. So okay, let me move to the next question. That is, here a cylindrical wire has a mass 0.3 plus or minus 0.003 gram, radius 0.5 plus or minus 0.005 millimeter, and length 6 plus or minus 0.06 centimeter. the maximum percentage error in the measurement of its density. We know that density is equals to mass by volume. Then volume of the cylindrical wire can be expressed as pi r square L, length of the wire. Now we need to find out the percentage error. So we know that the relative error expressed in percent is called as percentage error. So relative error of this density is equals to delta rho by rho, which is expressed in percent, that is multiplied by 100, gives us the percentage error in density, that is percentage error in the measurement of density. So that is equals to, here we have mass, that is what we can write, delta m divided by m into 100%, plus here we have r square, so therefore 2 times delta r divided by r into 100% plus 100, and here we have L, that is equals to, that is delta L by L into 100. So this can be written like this, delta m, here we have 0.003 divided by 0.3, m is 0.3 into 100 plus 2 times delta r, here we have delta r is 0.005 divided by 0.5 into 100 plus delta L, here we have 0.06 divided by 6 times 100. Now 0.003 divided by 03 is 0.01, 0.01 into 100 is 1, plus here also this will become 0.005 divided by 0.5 is 0.01, 0.01 into 100 1, 1 into 2 2, plus here 0.06 divided by 6, 0.01, 0.01 into 100 is 1. So therefore 4, the percentage error in the measurement of its density is 4. Option D would be the correct answer. So moving to the next question, that is, at a metro station, a girl walks up a stationary escalator in 20 seconds. If she remains stationary on the escalator, then escalator takes her up in 30 seconds. The time taken by her to walk up on the moving escalator is, see, the girl walks up a stationary in 20 seconds. That means velocity of the girl can be written as the distance divided by time. Let me take t1, that is t1, and here the length of this L can be considered as length of the escalator. Now velocity of the escalator is equals to how much? That is the same length divided by, let me take this one as t2. Now we have here the effective velocity, that is velocity of both the time taken by her to walk up on the moving escalator. She is also in motion and escalator is in motion, so therefore we have to consider velocity of the girl plus velocity of the escalator. So the velocity, the effective velocity is equals to t divided by the time, total time, is equals to Vg, that is L divided by t1 plus L divided by t2. Here L and L get cancelled, so we'll get t is equals to t1 t2 divided by t1 plus 2, isn't it? Here we have here 1 by t1 plus 1 by t2, this is nothing but 1 by t. So therefore t can be written as t1 t2 divided by t1 plus t2. Now on substituting t1 here, that is 20 seconds into t2 equals to 30 seconds divided by 20 plus 30. So this is equals to t equals to, so we'll get here 600 divided by 50. This and this get cancelled, we get 5, 12. So t equals to 12 seconds. So option C is the right one. Moving to the next question, that is, rain is falling vertically with a speed of 12 meters per second. A woman rides a bicycle. With a speed of 12 meters per second in east to west direction. What is the direction in which she should hold her umbrella? Here, the velocity of the rain is like this. That is velocity of the rain is 12 meter per second, and in the downward direction. That is next velocity of the bicycle, that is woman. She is moving from east to west. This is east, west, north and south. So she is moving like this. Now velocity of the woman or bicycle is equals to 12 meter per second. Now what is the direction in which she should hold her umbrella? Here we know that the relative velocity of the rain, it is the relative velocity of the rain. Let me write relative velocity of the rain with respect to bicycle is equals to VR minus VB. VR minus VB. But here VB we have, so therefore let me consider the minus VB. The magnitude remains same, but the direction is opposite. This is minus VB. So she must hold her umbrella to protect herself in the direction of a relative velocity of the rain with respect to what? In the direction of the relative velocity of the rain with respect to bicycle she has to hold. So that is, she has to hold in the direction of relative velocity. This is the direction of, that is the direction of relative velocity of rain with respect to bicycle. See here, she has to hold the umbrella in this direction. That is like this. She has to hold in this direction. So to protect herself, she has to hold towards west. Now we need to find out an angle. So as we know that the tan theta is equals to tan theta opposite. This is opposite. Opposite is VB. We have VB is equals to VB divided by adjacent. Adjacent is VR. So VB equals to 12 and VR is equals to 12. So therefore it is equals to 1. So tan theta equals to 1. So therefore theta is equals to 45 degree. Therefore, she should hold her umbrella in the direction of velocity of rain with respect to bicycle at an angle of 45 degree with vertical along west or towards west. Okay, so that is D is the correct option. Okay, moving to the next question, that is, one end of a string of length L is connected to a particle of mass M. So here length is L and it is connected to a particle of mass M, and other to a small peg on a smooth horizontal table. If the particle moves in a circle with the speed v, the net force on the particle directed toward the center is T is the tension in the string. See, one end of the string, let me consider, here is the table which is placed on the table, and one end of this string is fixed to this small peg, and other end, for the other end we have connected a particle of mass M, and this particle is moving in the circular path like this. So we know that if it wants to move in the circular path, there must be necessary centripetal force that must be acting toward the center. That is called as centripetal force here. So whenever we look at the forces acting on the particle, we know that the weight of the body is acting in the downward direction, and normal reaction is acting in the upward direction, and the force which is essential to move this particle in the circular path is centripetal force that is acting in the towards the center. Now this any particle, if it wants to move in the circular path, there must be necessary centripetal force. That necessary centripetal force will be given by the tension created in the string in this case. So therefore the force which is directed towards the center is the tension created in the string. So that provides the necessary centripetal force for the particle to move in the circular path. Okay, here the option A would be the right one. So moving to the next question, that is, a body is initially at rest. It undergoes one-dimensional motion with a constant acceleration. The power delivered to it at a time t is, as we know that power is equals to force times velocity. So force from the second law ma, and velocity can be written as u plus at, but here u is 0 because a body is initially at rest. So we could take this one as ma into at. This is equals to m a square t. Here m is constant, mass of the particle is constant, acceleration is also constant. So therefore here the power delivered to it at a time t is proportional to t. So therefore option B would be the right answer. Okay, so moving to the last question, that is, a thin uniform rectangular plate of mass 2 kg is placed in xy plane as shown in the figure. The moment of inertia about x-axis is 0.2 kg meter square, and moment of inertia about y-axis, that is Iy, equals to 0.3 kg meter square. The radius of gyration, we need to find out the radius of gyration here. Radius of gyration of a plate about the axis passing through O and perpendicular to the plane of the plate is. See, according to the perpendicular axis theorem, we know that the moment of inertia of the plate about the axis passing through O and perpendicular to the plane of the plate is, the perpendicular to the plane of the plate, that is Iz. Here Iz is equals to Ix plus Iy. From the perpendicular axis theorem we could write Iz is equals to Ix plus Iy. So here we have Ix is 0.2 and Iy equals to 0.3. So therefore it will become 0.5 kg meter square. As we know that the moment of inertia is equals to mass times the square of the radius of gyration. So therefore k equals to square root of I by m. So here, so Iz by m. Here we have Iz, that is equals to 0.5 divided by mass of the plate is 2 kg. 0.5 divided by 2 is 0.25. So that is equals to 0.5 meter. So this is nothing but 50 centimeter. So option A is the correct answer. Okay. Dear students, for previous videos you can click on the links which are mentioned in the description. And one more thing, please subscribe and hit the bell icon to get notification of our new videos. Okay, thank you for watching. Have a nice day.